the starlit mystery of Proxima b, in the vast emptiness of the cosmos, where stars burn like beacons in an endless night. A tiny speck of wonder orbits a dim red dwarf star just 4.2 light-years from Earth. Its name is Proxima Centauri b, or simply Proxima b, a planet that has captured the imagination of scientists, dreamers, and stargazers alike. On a crisp morning in 2025, astronomers unveiled the most breathtaking image of this distant world ever captured, a feat made possible by the unparalleled precision of the James Webb Space Telescope, JWST. This vivid portrait of Proxima b, glowing faintly against the cosmic void, has reignited humanity's oldest question. Are we alone in the universe? This is the story of Proxima b, a world both alien and tantalizingly familiar, a planet that dances in the habitable zone of its star, bathed in just enough stellar energy to spark dreams of oceans, atmospheres, and perhaps even life. It's a tale of cutting-edge technology, relentless curiosity, and the eternal human drive to explore the unknown. Join us as we journey to the edge of our solar neighborhood, unraveling the mysteries of Proxima b and pondering what its discovery means for our place in the cosmos. A star next door. To understand Proxima b, we must first meet its host, Proxima Centauri, the closest star to our Sun nestled in the constellation Centaurus. Proxima Centauri is a red dwarf, a small, cool star that burns with quiet intensity. Unlike the blazing giants like Regulus or Canopus, which dazzle the night sky with their brilliance, Proxima Centauri is faint, with a magnitude of 11.13, far too dim to be seen with the naked eye. Yet, its proximity to Earth, a mere 4.2 light-years away, makes it a cosmic neighbor of profound significance. Discovered in 1915 by Scottish astronomer Robert Thorburn Innes, Proxima Centauri is part of a stellar trio, the Alpha Centauri system, alongside its brighter companions, Alpha Centauri A and B. These two stars shine with a combined brilliance that ranks them among the brightest in the sky. But Proxima, the humble red dwarf, hides a captivating secret. It is the nearest star to our Sun, a fact reflected in its name, derived from the Latin word for nearest. Despite its faint glow, Proxima Centauri is a powerhouse in its own right. Red dwarfs, like the most common stars in the universe, and their slow-burning nature ensures they will outlive nearly every other celestial body, radiating energy for trillions of years. But Proxima Centauri is not a gentle host. As a flare star, it occasionally erupts in violent bursts of energy, hurling intense ultraviolet radiation and charged particles into space. These outbursts complicate the search for life in its orbit, yet they also make Proxima Centauri a fascinating subject to study. And orbiting this volatile star is Proxima b, a planet that has become a beacon of hope and mystery in the quest to find habitable worlds beyond our own. The discovery of a cosmic neighbor. The story of Proxima b begins not with a telescope peering directly at the planet, but with a subtle dance of light and gravity. In 2016, astronomers using the radial velocity technique, a method that detects the gravitational tug of a planet on its star, confirmed the existence of Proxima b. This revolutionary approach relies on the Doppler effect, the same principle that makes a siren's pitch change as it passes by. As Proxima b orbits its star, it causes Proxima Centauri to wobble ever so slightly, shifting the star's light spectrum in ways that sensitive instruments can measure. These faint spectral shifts reveal the planet unlike any other. Proxima b orbits its star every 11.2 Earth days, a dizzyingly short year compared to Earth's 365-day cycle. It resides just 4.6 million miles from Proxima Centauri, 20 times closer than Earth is to the Sun. Yet, because Proxima Centauri is so much cooler than our Sun, this close orbit places Proxima b squarely in the star's habitable zone, the Goldilocks region where temperatures might allow liquid water to exist. This discovery sent shockwaves through the astronomical community, marking Proxima b as the closest known exoplanet in a potentially life-supporting orbit. Proxima b is not alone in its system. Another planet, Proxima Centauri c, a larger world farther out, shares the orbital dance around the red dwarf. Together, these planets form a system that is both strange and tantalizingly familiar, raising questions about what other secrets Proxima Centauri might hold. The James Webb Space Telescope, a window to the stars. Enter the James Webb Space Telescope, humanity's most advanced tool for peering into the cosmic abyss. Launched on December 25, 2021, after years of delays and meticulous engineering, JWST is a marvel of modern science. Its 6.5-meter primary mirror, composed of 18 gold-coated hexagonal segments, captures light from the universe's farthest reaches with unprecedented clarity. Unlike its predecessor, the Hubble Space Telescope, JWST is optimized for infrared observations, making it uniquely suited to study cool, distant objects like Proxima b. In 2025, JWST turned its gaze toward Proxima Centauri, capturing the most detailed image of Proxima b ever obtained. This image, a faint glow against a starry backdrop, is more than just a picture. It's a scientific triumph. Proxima b does not emit its own light, so imaging it directly is a monumental challenge. Instead, JWST relies on detecting the infrared radiation that the planet absorbs from its star and re-emits. This process, known as thermal emission, allows scientists to infer details about the planet's surface, atmosphere, and potential habitability. The telescope's sophisticated sensors can detect subtle variations in light, revealing clues about Proxima b's composition. Could it have an atmosphere? Might it harbor liquid water? These questions drive the scientists analyzing JWST's data as they search for the chemical signatures, known as biosignatures, that could indicate the presence of life. A planet of contrasts. Proxima b is a world of stark contrasts. Because it orbits so closely to its star, it is likely tidally locked, with one hemisphere perpetually facing Proxima Centauri in eternal daylight, while the other is shrouded in endless night. This creates a planet of extremes. One side scorched by stellar radiation, the other frozen in darkness. At the boundary between these two hemispheres lies the twilight zone, a narrow band where temperatures might be just right for liquid water to exist. Proxima b is estimated to be about 1.17 times the mass of Earth, making it a rocky, terrestrial planet rather than a gas giant like Jupiter. Its size and density suggest it could have a solid surface, perhaps with mountains, valleys, or even oceans, but its environment is far from Earth-like. Proxima Centauri's flares bathe the planet in intense ultraviolet and X-ray radiation, which could strip away any atmosphere over time. Without a robust atmosphere to shield it, Proxima b's surface might be a barren wasteland, scorched and sterile. Yet, there is hope. Some models suggest that Proxima b could retain a thin atmosphere, possibly containing nitrogen, oxygen, or even water vapor. If the planet has a strong magnetic field, it might deflect some of the star's harmful radiation, creating a protective bubble for potential life. Scientists are also exploring the possibility of subsurface. Yet, there is hope. Some models suggest that Proxima b could retain a thin atmosphere, possibly containing nitrogen, oxygen, or even water vapor. If the planet has a strong magnetic field, it might deflect some of the star's harmful radiation, creating a protective bubble for potential life. Scientists are also exploring the possibility of subsurface oceans hidden beneath a frozen crust, similar to those found on Jupiter's moon Europa. These hidden reservoirs could harbor microbial life, shielded from the harsh stellar environment. The quest for life. The question of habitability lies at the heart of Proxima b's allure. Does it have water? An atmosphere? Conditions suitable for life as we know it? These are not easy questions to answer. Proxima b's proximity to its star means it receives about the same amount of stellar energy as Earth does from the Sun, placing it firmly in the habitable zone. But habitability is about more than just temperature. A planet needs a stable atmosphere, protection from radiation, and the right chemical ingredients to support life. The James Webb Space Telescope is uniquely equipped to tackle these questions. Its infrared instruments can analyze the light passing through Proxima b's atmosphere, if it has one, searching for molecules like water vapor, methane, or carbon dioxide. These molecules could serve as biosignatures, hints of biological activity. For example, the presence of methane and oxygen together could suggest the activity of microorganisms, as these gases are often produced by life on Earth. But scientists urge caution. As astrophysicist Dr. Elena Turner from Princeton University points out, an atmosphere does not guarantee habitability. Venus, Earth's closest planetary neighbor, has a thick atmosphere, but is a hellish world of crushing pressure and searing heat. Proxima b could be similarly inhospitable, with an atmosphere choked with toxic gases or surface temperatures too extreme for life. Alternatively, it might be a barren rock, stripped of its atmosphere by eons of stellar flares. The truth lies in the data, and JWST is humanity's best hope for uncovering it. The cosmic context. Proxima b is just one of countless exoplanets scattered across the universe. With an estimated 200 billion stars in the Milky Way alone, and many more in the observable universe, the number of planets could be in the trillions. Some, known as rogue planets, drift through space without a star, untethered cosmic wanderers. Others, like the gas giants known as hot Jupiters, orbit so close to their stars that their surfaces glow with molten heat. There are also many Neptunes, super-Earths, and worlds that defy categorization, each adding to the rich tapestry of the cosmos. The discovery of Proxima b has galvanized the search for exoplanets, driving advancements in detection techniques. In addition to the radial velocity method, astronomers use the transit method, which measures the slight dimming of a star's light as a planet passes in front of it. This technique has revealed thousands of exoplanets, many in their stars' habitable zones. Each discovery brings us closer to answering the ultimate question: are we alone? The search for biosignatures is a key focus of exoplanet research. By analyzing the light from a planet's atmosphere, scientists can detect gases like oxygen, methane, or nitrous oxide, which are often associated with life. JWST's ability to perform this analysis across vast distances makes it a game-changer in the hunt for extraterrestrial life. If biosignatures are found on Proxima b, it would be a monumental discovery, suggesting that life is not unique to Earth. Dreams of exploration. Proxima b's proximity to Earth, 4.2 light-years, is a mere stone's throw in cosmic terms, makes it a tantalizing target for future exploration. But reaching it is no small feat with current technology. A spacecraft like Voyager 2 would take roughly 73,000 years to reach Proxima Centauri. Yet, human ingenuity is already pushing the boundaries of what's possible. Concepts like light-propelled solar sails, ultra-thin materials driven by the momentum of photons, could reduce the journey to just 20 years. Such innovations bring the dream of interstellar exploration within reach, if not in our lifetimes, then perhaps in those of our children. For now, Proxima b remains a distant enigma, its secrets locked in the light that reaches JWST's mirrors. Each new observation brings us closer to understanding this world, its surface, its atmosphere, its potential for life. But even if Proxima b proves to be uninhabitable, its discovery has already reshaped our view of the universe. It reminds us that the cosmos is teeming with worlds, each with its own story to tell. A beacon of wonder. The image of Proxima b captured by the James Webb Space Telescope is more than a scientific achievement. It's a symbol of humanity's relentless curiosity. It represents our drive to explore, to push beyond the boundaries of our world, and to seek answers to questions that have haunted us for millennia. Is there life out there? Could Proxima b be a second Earth, or is it a stark reminder of how unique our planet is? As we gaze at the stars, Proxima b stands as a beacon of possibility. It challenges us to imagine a universe where life is not a solitary miracle, but a common thread woven to the fabric of the cosmos. Whether it holds oceans, atmospheres, or even the faint stirrings of life, Proxima b is a testament to the power of science to illuminate the unknown. In the end, the story of Proxima b is not just about a single planet. It's about humanity's place in the universe, our quest to understand the stars, and our unyielding hope that somewhere in the vastness of space, we might find a world that feels like home. Echoes from the Twilight Zone, the image of Proxima b, glowing faintly in the infrared gaze of the James Webb Space Telescope, is more than a snapshot of a distant world. It's a window into a realm of possibilities. This enigmatic planet, orbiting the red dwarf Proxima Centauri, teeters on the edge of habitability, its surface a canvas of extremes. Scientists speculate about its twilight zone, that narrow band between eternal day and endless night, where conditions might be just right for life to take hold. Could this strip of temperate land harbor pools of liquid water, cradled in rocky basins? Might it be home to alien ecosystems, whispering secrets of biology unlike anything on Earth? The twilight zone of Proxima b is a place of fascination and conjecture. Tidally locked to its star, the planet presents one face to Proxima Centauri's fiery glow, while the other languishes in perpetual shadow. The day's side could be a scorched desert, battered by ultraviolet flares, while the night's side might be a frozen wasteland, locked in an icy grip. But at their boundary, where light and darkness meet, temperatures could hover in a range where water remains liquid, a prerequisite for life as we know it. Scientists envision rugged landscapes in this twilight zone, jagged cliffs softened by the dim, reddish light of Proxima Centauri, perhaps dotted with pools that reflect the star's faint glow like scattered jewels.